In this video, we'll write the net ionic equation for ZnCl2 plus Na2CO3. This is zinc chloride and this is sodium carbonate. First thing we need to do with these net ionic equations is balance the molecular equation. The molecular equation, this is the molecular equation, we could just put a 2 in front of the NaCl and that would be balanced. So we've done that. Then we need to write the state for each substance. So zinc chloride, we're going to assume that both of these are going to be aqueous. They're both soluble. Aqueous. So they're both dissolved in water and they'll both split apart into their ions. Zinc carbonate, carbonates often aren't soluble. So we should either have memorized the solubility rules for this or we could just look them up on a solubility table. So if I look for zinc here, I can find zinc down at the bottom, carbonate right here. So as I go down and over, I have this I. It's insoluble. So zinc carbonate's not going to dissolve. It's not going to break apart into its ions. In fact, it'll be a precipitate. It'll fall to the bottom of the beaker or test tube as a solid. Let's put an S there. And then sodium chloride, sodium compounds and chloride compounds, very soluble. Let's just put a little AQ for that. Next, we're going to split these strong electrolytes into their ions, and this will give us the complete ionic equation. So the strong electrolytes, those are the ones with aqueous, and to do that, we need to know the charge on these compounds. Zinc is kind of odd. It's a transition metal, but it always has a 2+ ionic charge. Chloride ion, that has a 1-. Sodium is in group 1 on the periodic table. It has a 1+ ionic charge, and you can tell that the carbonate's going to have to be a 2-. But you can also memorize that carbonate ions are 2-. Zinc carbonate, we're not going to split up into its ions. Then we add positive for the sodium, the chloride ion is negative. So we have the ionic charges, now we can split them up. Zinc Zn2+, and I won't write aqueous each time, we'll do that at the end, plus the chloride ion, Cl- and the 2, that means we have 2 of those. Then we have sodium ion, Na+, and we have 2 sodium ions plus the carbonate ion, CO3 2-. So these are the reactants. Let's do the products. We said we don't split up solids in net ionic equations. So this just turns out to be ZnCO3, that zinc carbonate as a solid, plus we have 2 sodium ions and then 2 chloride ions. So now we have the total ionic equation, we can cross out these spectator ions. They appear on both sides of that complete ionic equation. So let's see, Zn2+ on the reactants, we don't have that in the products. 2Cl- reactants and products, we can cross that out. 2Na+ in the reactants and 2Na+ in the products, cross it out. Everything else is unique. So this gives us the net ionic equation. We have our Zn2+, our carbonate ion, and then ZnCO3, which we said is a solid. So this is the net ionic equation. Let me clean it up and format it nice and add the states in. And this is our net ionic equation for zinc chloride plus sodium carbonate. This is Dr. B, and thanks for watching.